Let's consider the limit as x approaches 0 of this sum of rational functions 1 over x squared minus x plus 1 over x. Now, based on our limit properties, our initial approach to this might be to say, well, let's split it into the sum of the limits. And so we could say, all right, let's try the limit as x goes to 0 of 1 over x squared minus x plus the limit as x goes to 0 of 1 over x. And interesting thing here is as x goes to 0, if x is positive, but getting close to 0, then we have 1 over a very small number, which is a very large number. If x is negative but approaching 0, we have 1 over a very small negative number, which is a very large negative number. So it's either going to be plus or minus infinity over there. And over here, similarly, the square kind of dominates here. So as x goes to 0 here, we're going to have a very small number squared minus a very small number. So let's see, that's going to be smaller minus not so small. We're going to have a negative result there. So a negative infinity. And if x is negative, then we'll have what, a very small number minus a negative small number, so 1 over a positive small number. Yeah, so it's going to be minus or plus infinity, kind of the reverse of what's going on over there. So what does that really mean? And the answer is nothing. The limit law says you can only split the limit across a sum if the limits exist, and these limits do not exist. So that approach is not valid here. We're going to do something else. So what we'll do is we'll just apply a little algebra to this to see if we can clarify it in any way. Now, we might take a look graphically just to try and get a hint as to what's going on. So if I go and graph this thing, here's the function, 1 over x squared minus x plus 1 over x. And I'm letting x go to -1. Let's see, no, I'm letting x go to 0. And oh, look at it, it says there's a point there. Double check, what is f of 0? Wait a minute, infinity. But up here it says it looks like -1. What the heck is going on? GeoGebra is struggling with this. And so are we at the moment. Good. Makes it more exciting. All right, algebra, what should we do? Well, we should carry out this addition. So factoring that denominator in the first one would be x times x minus 1 in the denominator. So that looks like that's going to be the common denominator. So we'll multiply bottom and top by x minus 1 here so that we can perform the addition because we need a common denominator. So now our numerator is 1 plus x minus 1. Our denominator is x times x minus 1. Numerator cleans up nice, right? 1 minus 1 is 0. 0 plus x is x. So this is now x over x minus x times x minus 1. And then I can see I have a number divided by itself, which is 1. So this cleans up. That sum is another version of 1 over x minus 1. And now if I take the limit as x goes to 0 of this new version, which is equal, based on my algebra, to the original with a slight catch. The original one, the domain here is all real numbers except x equals x could not be 0 and x cannot be -1, or no, +1, sorry. And so that's still true here. And you might say, uh-oh, we're going to 0, but remember, a limit is approach, not get there. So we're still okay. These two things are equal for all numbers except 0 and 1, and that's all right. And we can apply a limit law here that says take the limit of the numerator, which is 1, take the limit of the denominator, which is -1, and so it looks like the result is -1. Now, I just want to be clear about something. We've just shown that the limit of this right here is -1. But f of 0 does not exist. There is no point on this function when x equals 0, even though the limit exists. And graphically, the graph is just showing us, yeah, well, if you approach from the left, y will come to -1. If you approach from the right, y will come to -1. But at -1, you got nothing. And GeoGebra says it's infinity, but it's actually not infinity. Clearly, that's not infinity, that's -1. The function does not exist there, but the limit does. We have a little hole in the graph there. That's it.